Definition of functions. Examples of graphical continuous functions. Picking up where we left off in the first part of this video sequence, consider now these four examples of relations. The first example is set A and B that constitutes a function through a one-on-one correspondence of set values, except for value 28 that does not belong to the range. The second example is the same as the relation between sets A and B, with the exception that set C has one less value on its codomain, being a complete one-on-one correspondence between sets, where the codomain coincides with the range. The third example is not a function, since an input value of set D corresponds to two output values of set E. The last example presents a function I with the particularity of two values of set F corresponding to the same output in set G. We can conclude that the relation one-to-many is not allowed, like in our example of sets D and E, but the many-to-one relation is allowed and represents a function like in our example of sets F and G. Note: an ordinary function is a single-valued function, like in our examples of functions f, g, and I. A one-to-many relation can still exist. They are called multi-valued functions, although our topic here is just functions, which are single-valued functions where only one-to-one and many-to-one relations can exist. Now, to a better understanding, let's represent these relations using coordinates in a Cartesian reference frame. And, for better representation, the scale on the y-axis is considered different from the one on the x-axis. We will also consider linear connections between these points, meaning that we will have linear continuous functions represented by straight lines. Let's first analyze sets A and B. A simple trick to see if this relation is a function using a graphical representation is through the use of a specific test, the vertical test. This test consists of passing a vertical line throughout the graph path. If this line intersects more than one point for a certain value of x, it means that this relation is not single-valued, and thus it is not a function. In this case, throughout the function, the vertical line only intersects one point, meaning that in this relation x always corresponds to one y, a one-to-one relation, and so f is a function. The domain, codomain, and range will have a slight change. Now that we have a linear continuous function, we will have intervals instead of specific sets of points. Additionally, the domain and range can be more easily perceived in the graphical representation, respectively in the x and y axis. The concept of continuous functions can be seen here, which means that we don't have any discontinuities along the function. One simple way to see this is by using a pencil following the path of our function. If we have to raise our pencil during this, then it means that there's a discontinuity and the function is not continuous in its domain. In this video, we will only consider continuous functions. Hence, function f is a continuous function. Let's see the relation between sets A and C. The vertical test confirms that this relation is a function. And by applying the test of continuity, this function is verified to be continuous in its domain. The relation between sets D and E shows a continuous function. However, when applying the vertical test on the graph, we can verify that for x equal to 5, we will obtain more than one value for y, between y equal to 8 and y equal to 14. So this is a one-to-many relation which is not allowed, and thus relation h is not a function as previously mentioned. The last relation is between sets f and g and passes both tests. Being a continuous function, in which for values of x between 8 and 12, we will always have the same value of y, 21. It presents a many-to-one relation, which is allowed in ordinary functions. In perspective, we have three examples of ordinary functions, single-valued or simply just functions, and one that is not a function.